All right, continuing with the 6.1 examples. This is example 6.3, and it's very specific. It's kind of important if you're really doing research. You're as specific as possible, but I wrote up most of the problem condensed. The mean height of a 15 to 18-year-old males from Chile in 2009 was 170 centimeters with a standard deviation of 6.28 centimeters. And male heights are normally distributed. That's one of the valuable things about normal distribution. Stuff like this is distributed like that. This is an age range that isn't necessarily the full adult height, which is usually what I think about in these examples, but this is specifying. We're talking about teenagers. So 170 centimeters, so don't worry about it. It's regular height for a 16-year-old boy. But for this data, we're going to use the variable x to represent the height of a 15 to 18-year-old male from Chile in 2009. So that's the meaning of our variable x. To condense this whole statement, I can say that that variable x is distributed normally with a mean, the mean height, blah, 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 is 170, and a standard deviation, 6.28. So that actually contains all the information in this paragraph here. It boils down to this. We've got the mean, we've got the standard deviation. Now we're going to be able to answer some questions based on that. So I'm going to keep just that piece for now. And for part A, suppose a Chilean young man, well, of course, according to the specifics of the problem, it has to be 15 to 18 years old, male in 2009. So, but that's where we're going from. Was 168 centimeters tall in 2009. And then find z-score is the situation here. We want to find the z-score, so I'm going to put the z-score formula x minus mu over sigma. In this case, the x is 168, the mu is 170, and the sigma is 6.28, and this comes out to negative 0.32. No units. The height, the mean, and the standard deviation are all measured in centimeters. But if we got centimeters minus centimeters, that's centimeters. And then centimeters divided by centimeters, they cancel. There's no units for the z number, or for the z-score. One thing I want to point out, though, is this person is shorter than average. So the z number is negative. If they want an interpretation or an interpretive sentence about this, I'd say 168 centimeters is 0.32 standard deviations below the mean, as signified by that negative sign, or to the left of the mean. Let's look at a different part for this example. Suppose the height of a a z-score of 1.27. How tall is he? So, first of all, he is not 1.27 centimeters tall. That doesn't even make sense. But we can rebuild his actual original height measurement from his z-score using the population mean and the population standard deviation. It's not the formula. We've been doing z equals x minus mu over sigma. If you rearrange this and solve it for x equals mu plus z sigma. In this case, that's 170 is the mean, plus the z-score we're given, 1.27, times the standard deviation of 6.28. And that comes out to 177.98 centimeters. That's what we're trying to find in the second question. How tall was this person based on his z-score?